Okay, in part 2 of the snake game video, I asked you to solve a particular problem, a small problem in this program, and that was how to get the turtle to not reverse its direction, or in other words, how to prevent the user from being able to do this, which is to make the turtle reverse its direction and go back on its own tail, essentially. It's okay if the turtle moves left or right, we just don't want the turtle to go backwards. So that's a question of limiting the control that the user has. A quick note on solutions to problems. There's always more than one way to solve a problem in programming. And a lot of times you can tell a person by their solutions. You can look at a program and you can tell that it is the unique solution of a person. The more complex a program gets, the easier it is to identify, the particular, I don't know, it's like a fingerprint on a piece of code. That's part of why problem solving is a creative process, and it's part of why it's enjoyable to do. So when I offer you a solution, it's going to be one solution, or it's going to be the solution that I came up with. Hopefully you have tried to solve this problem already. You may have come up with something different. It doesn't mean that your solution is wrong. It doesn't mean my solution is right. Sometimes we can compare solutions to determine, with particular reasons why one solution might be better than another, and those are interesting conversations to have. But it's good to know that there's not always only one right answer. So, with that in mind, we're going to take a look at one possible answer. To go over what this program already does, this program keeps track of the direction that the turtle is supposed to be moving. And this is, let's call the turtle the snake, because eventually it's going to be a snake. So the snake is going to be moving in a particular direction, and the user is allowed to use key presses to change that direction. What we want to do is prevent that direction change from being the opposite direction of what it is. So already in the way, sometimes describing a problem starts to lead you to a solution. So as I said this, as I described the problem, I said prevent the snake from moving in the opposite direction that it's moving. So right in describing it, you can hear that I need to know what direction it's moving to solve this problem, because I need to know what the opposite direction is, because that's the direction I want to prevent you from setting the snake's direction to. So let's see how this works. I made one change to this program to make it different from the previous program, which is that this now uses the up, left, down, and right keys instead of W, A, S, and D. It's just I like the arrow keys better for moving my for changing the direction of my turtle, so I've just used that instead. So this is the code that actually causes those changes to happen. Go up is the routine that's called, the behavior, when the up button is pressed. These are the strings that represent the up arrow, the left arrow, the down arrow, and the right arrow. Instead of the letter for a key, just like the X key is X, the actual word up represents the up arrow. Okay. So let's look in this program where the change in direction actually happens. So here are the responses to the user input. So when the left key is pressed, it calls go left. And so it sets the turtle's behavior to left. So right here, the actual behavior of the turtle is changed. This is where the turtle remembers its behavior, and this is where that turtle changes its behavior. So if we wanted to prevent the turtle from going left for some reason, let's say we just wanted to stop it from going left, we could just tell it to not do this. Right? We could tell it, let's see. So we could comment this out, and then it would never go left. So let's run this. I tried to go left there, run it again. So I can go down, I can go up, I can go right, but I can't go left. Because no matter how I press that button, you can actually see the message scrolling up, because you can see it's still calling the go left routine, but it won't go left. Okay. So we can stop it from going left by interrupting that, but we only want to stop it from going left when it's going right. And when we want to do something in a certain condition, but not all the time, that sounds like a decision structure. That sounds like an if statement. So to put it in English words, if it's going right, don't allow it to go left. And an if statement is how we do that. So how do we know whether it's going right? Well, turtle.behave is keeping track of the behavior for us. So we can check the behavior. We can say if turtle.behave equals right. But wait a minute. So we don't want to check if it's going right. We want to do this if it's not going right. So when we want to check if something is equal to something, we say, if turtle.behave equals right. If we want to check whether it is not equal, or if we want the condition to be something to happen when it's not equal, we use the exclamation point and equals sign, which means in Python, not equal. So if turtle.behave is not equal to right, then go ahead and set it to left. It's okay to make it go left as long as the direction currently isn't right. So we're going to use this same pattern. Well, let's actually test it. So I'm going to run, and so I can go backwards if I'm going down, but I can't go backwards if I'm going right. I can still do it in the other directions, so I can still reverse my direction, but if I'm going this way, I can't. So that worked. So the secret to the solution to this problem was was just checking where the behavior is changed and prevent it from happening under the right circumstances. So I'm going to copy and paste to make things go quicker. Okay, so if it's going right, if it's not going right, it's okay to make it go left. If it's not going left, it's okay to make it go right. If it's not going down, it's okay to make it go up. If it's not going up, then it's okay to make it go down. And now the turtle or snake cannot go backwards. It can only turn, from its perspective, it can only turn left or right. So it can only change direction at right angles now instead of doing a 180.